In today's lecture, I'm deriving very important relationship, which is the torque and angular acceleration for a rigid body. So how we can relate the torque, that is turning force, with its angular acceleration. So this is actually the rotational analog of Newton's second law for a rigid body. So let's start with definition of torque. The tau, which is torque about axis z, will be given by r times p. If angle between f and r is 90 degree, then we can write down in this format. Actually, tau c is r cross f, which is equal to r f sine of theta. Let's say theta is equal to 90 degree. In this situation, we can write it down sine theta is equal to sine 90 degree, which is 1. So with this situation, let me rewrite this equation again, which is tau z equal to ref. We know from Newton's second law of motion, F equal to ma. Let me insert this value over here. I will be getting tau about z axis equal to rma, which is Newton's second law of motion. There is relationship between the linear acceleration and angular acceleration. Relationship between linear and angular acceleration is given by a equal to r alpha. So this is actually tangential acceleration is equal to r, the radius of the circle in which object is rotating, and alpha is angular acceleration. So let me put this value, the acceleration, over here. So I will be getting tau z will be equal to r m r alpha. Okay, so alpha here is angular acceleration and this is about z axis. So just rearranging this equation, tau z is equal to m. There are two r's over here, so I can write down like mr squared and then alpha z. Okay, if you look at very carefully, this mr square is I, which we call moment of inertia. So tau of z about z axis equal to I alpha z. So this is important relationship. Look at here, the angular the torque is equal to the product of moment of inertia times angular acceleration about z axis. Okay, so this is actually the rotational analog of Newton's second law of motion for rigid bodies. So let me rewrite Newton's second law of motion. According to Newton's second law of motion, F equal to ma. What is F here? F is force applied on an object or system of the bodies. The m is the mass and a is acceleration, which is linear acceleration. So this equation here, the tau z equal to I alpha z, this is very analogous. Look at here, what is this F? This is the force applied in that causes the linear motion, and this is the tau. This is a kind of force that we call torque. It causes rotational motion. So the force in linear motion is equivalent to torque in angular motion. Okay, so this is left hand side of this equation. So go to another equation, another side, which is right hand side. This is linear acceleration. Linear acceleration, and this alpha g is angular counterpart, angular acceleration. So these two are basically acceleration. The first one is the linear and second one is angular acceleration. So what is this? This quantity is mass, and this one here is moment of inertia. Moment of inertia, and look at here. I is actually mass times the radius squared. So moment of inertia is equivalent to mass in case of rotational motion. So the moments of inertia plays the same role as mass plays in the linear motion. So that's why we can relate these two equations as an analogous equation.